Hello friends, in this class we'll see area related to circles introduction. What it says in this chapter is there are two formulas and there will be 4 marks question from this chapter. Very important and application type of problems will be asked in the exams. As we have seen in the previous class, this sector is nothing but it is the area between the radii and two radii and arc of the circle. This is called sector. What is this? Area between the chord and the arc is called segment. Okay, segment. If arc is minor, if arc is minor, minor means it is small in the size. This is a small in the size. The other part will be bigger one. So if arc is minor, segment becomes minor segment. If arc is major, it becomes major segment. Okay. In the same ways, if arc is minor in the sector part, this is called, if arc is minor, it is called minor sector. If arc is major, it's called major sector. So here, if I put one more letter, OACB is a minor sector. Okay, it's a minor sector. We take another letter here, it's a minor sector. We take another part, that is OADB. It is a major sector. Okay, this is one thing. Sector and segment. What actually being taught in this chapter is, before that we'll just see recap that circumferences of a circle is 2 pi r, area of a circle is pi r square, area of a quadrant is what? How much? This one part is a quadrant. So 1/4 of the circle, that is 1 by 4 pi r square. We know diameter is 2r, so circumference becomes pi d. Okay, so these are just a recap. Coming to this, if this is a sector, what is the length of ACB? See, length of ACB means ACB is a arc here. Remember, ACB is a arc. So length of arc, what is the formula? This is a arc. Length of arc is theta by 360. Remember, this is very easy formula. We can remember easily. Theta by 660 into 2 pi r. That is circumference you have to put. What is theta? Theta is the angle of the sector which is made between the radii and the arc. So this is length of arc of a sector. Okay. Remember, this is the length of arc of a sector. What is the area of the sector? See, area of sector OACB is same way theta by 360 into, since area is asked, we have to write area of a circle. I have given a clue. For the length of the sector, you have to write the circumference. Theta by 360 is the common part. Check out in both. So basically we have two formula. Length of a sector is theta by 360 into 2 pi r. Area of a sector is equal to theta by 360 into pi r square. How do we remember? Remember, length of a sector, theta by 360 is the common part. So I hope you understood now. When they ask length of a sector, you have to multiply by length means what? Circumference is nothing but a length of a circle. So use 2 pi r there. Area of a sector they ask means you have to use pi r square, means theta by 360 into pi r square. Okay, we'll see two different formulas here. For example, if this is a circle and this is a sector and this is a chord, this is a segment O A B C. So if they ask area of segment, what is the segment here? Minor segment here, right? ACB, that is ABC. See, this is a segment. Segment is nothing but area between the chord and the arc. So area of minor segment ABC is what? Area of minor segment is nothing but what you know. Area of sector we can find, and area of triangle AOB. Area of triangle AOB. You subtract, you get ACB. That is area of sector AOB minus area of triangle AOB. Don't get confused AOB word. That's the reason I wrote area of sector behind AOB in the area of sector part. So this is area of minor segment. What is area of major segment? When you have minor segment, major segment area is nothing but circle area minus minor segment area. That is, see, area of major segment is equal to area of circle minus area of minus segment. These application problems we'll be seeing when we start actual exercise of this chapter later in the classes. Just I'm giving a brief how we have to start the exercise. What is needed, prerequisite for that. So area of major segment is nothing but area of a circle minus area of minor segment. Similarly, if you come to here, what is area of a major sector? Same, area of major sector is same way area of major sector is area of circle minus area of minor sector. Area of minor sector formula we have seen just now, theta by 360 into pi r square. Okay. By default, if nothing is given, it's a minor sector. Okay. So this is the area of the major and minor segment. Remember, area of segment is very important. It's a 4-mark question. Direct question will be there in exam. 1 4 marks question. Direct question. We will be using here trigonometric ratios to find the length of AB here. Because area of triangle, how do you find? There are 2-3 cases. When in a right angle triangle, half into base into height. There is no right angle triangle here. It's just AOB. So we need a height here, half into base into height. So for that we construct this perpendicular distance from O to B, call it as D. We calculate D here. Theta is given. We bisect it. So it's a big process. So that's the reason I told area of segment is important question. Okay. One example is there, 2-3 exercise questions are there. We'll see them when we start the exercise. So for time being, what is to be taken away from this class is these two formulas. Length of sector is theta by 360 into 2 pi r. Area of sector is theta by 360 into pi r square. Then these two concepts. Area of minor segment is area of sector minus area of triangle. Similarly, area of major segment is area of circle minus area of minor segment. Similarly for sector as well. Okay, thank you.